Good day, everybody. We are studying the concept of arc length. So we need a circle. Okay, having got that circle, let's move on. Now we need a tangent line. So this is the tangent, and it is a point of contact. And there are two questions here. Check if this is a tangent. If so, find the arc length. So I'm going to take this as O, this point as T, this point as P, and this point as A. So I'm going to say find the arc length dA. So there are two things that we need to do. We need to check if this is a tangent. Now the measurements given is not to scale. So they are given this length as 12, this length as 8, and this entire length is given as 16. Okay, so you can pause the video and complete this question. Okay, so this is the solution. If TP is a tangent to the circle, then by tangent theorem, the angle between the radius and the tangent is equal to 90 degrees. So this is the radii. So this angle is going to be 90 degrees. So this means triangle OTP is right angled. So this in turn means we can use Pythagoras theorem. So by Pythagoras theorem, you have OT squared plus DP squared is equal to OP squared. So I do not have OT squared, but I have TP squared, and then this entire length is actually 20, right? 12 plus 8, so 20 squared. Now this is going to be 20 squared negative 16 squared. 20 squared, that's 400. 16 squared is 256. You subtract these two, you get 144. So OT squared is 144. So OT is square root of 144, which is equal to 12. Okay. So if I square this and add this, the square of this, then I should get the square of this. So let's check. 12 squared plus 16 squared is equal to 20 squared, right? So 12 squared is 144, 16 squared is 256. So you add 256, what do you get? 10, 1, 10, 1, 400. 20 squared is 400. So we are actually ensuring that the Pythagoras is being proved. Okay, so that is the first part of the question. Now let us go one step further. This is by Pythagoras. Now let me give a relationship using the tangent secant formula. So what is the tangent secant formula? States pt squared or tp squared. So let me take it as pt squared. Pt squared is equal to OP squared negative r squared. So 16 units. You square it. The radius is 12. Right. So OP squared negative 12 squared. So this is going to be 256 plus 144 is equal to OP squared. So OP squared, you add these two, you get 400. So OP is equal to root of 400, which is equal to 20. So this is by the tangent secant relationship. Of course, once you get the Pythagoras, so you can ascertain that it is indeed a tangent. So having given you that information, let me move on. Okay, so we can also go one step further in ensuring that these sides which I've got form the sides of a right triangle. So how do we do that? We will have to get the following angles. So let me get this angle alpha. So what do we have? We have a right triangle. At least we have just seen that. So this side is 12 units. So this angle I'm taking it as alpha. This is 90 degree. This distance is 16. And this entire length is 20 units. So the angle or the side opposite is going to be our opposite side. This is our adjacent side. This is our hypotenuse side. Now I'm going to use sine alpha first. Is opposite side divided by hypotenuse side. So my opposite side is 12 units. Hypotenuse side is 20 units. 4 divides here 3 times, 4 divides here 5 times. So sine alpha is 3 over 5, which means you get 0.6. So alpha is sine inverse of 0.6. So let us check out this sine inverse of 0.6. So sine inverse of 0.6 is giving us an angle of approximately and 36.87 degrees. Now you have to observe here, I have actually rounded this up, okay, but you see the value that trigonometry is producing me, 36.86989765. So this is a complete number. Please have that in mind. What do I exactly mean by this? It means that if I were to add this number to its counterpart, it will produce me 90 degrees. That is the reason I am rounding it here. Because there is this question of what is called as error in rounding. And that would mean we are actually approximating. If we are approximating, how do we claim that these sides form the right triangle? So there is that question. To negate that question out of the scene, I am just showing you the value that we are producing. And the justification that I am rounding here is because we are getting a complete number. I hope that answers this question. So if I were to find the other angle, say beta, so I'm going to use I can actually use the same opposite side. I can find this angle also. So if I were to take sine beta is opposite side by hypotenuse. Hypotenuse is 20. So 4 divides here 4 times, 4 divides here 5 times. So sine beta is 0.8 and beta is sine inverse of 0.8. So let me check that out. Sine inverse of 0.8 is, you see that I am getting 53.130125. So this is what I'm getting. So what I'm going to do, I am going to be approximating it to 53.13 degrees. Now alpha added with beta should give me this angle gamma. Okay, say this is the gamma that I've got. So this gamma is my 90 degree. So clearly 36.87 added with 53.13 gives me 90 degrees. Is it not? So you have 36.87, 53.13, 10, 1, 10 and 10 and 9. So that is a valid justification that the sides that we are obtaining or we have got is actually the sides of a right triangle. Now I have done all this explanation just to make the element of understanding crystal clear. But in exams, if they are asking you show that the sides form the right triangle, all you need to do is just go and get the Pythagoras theorem proved. Pythagoras. Okay, so where did we exactly do that? This is the point. Okay, so this is where we got the result. Now we have the next part of the question. The next part of the question is find the arc length. They want us to get this arc length. Now this angle beta is found to be as 53.13 degrees. Okay, so that is there. Now how do we get this arc length? There is a formula. Let me show you this formula. Arc length, which is represented by L, is given as R times theta. Now if theta is in radian measure, you have to use this formula. But if theta is not in radian measure, if theta is in degrees, then L is equal to R times whatever value of theta that you have to multiply it by pi over 180. So this is the conversion factor. So this pi over 180 actually got a value of 0.0174533. So you can have this in the corner of your mind so that you can use it directly. So in our case, we are going to get this arc length, which is indicated here. So for that, I will be utilizing this angle, and the radii is 12 units. So L is equal to 12 units times 53.13 multiplied with 0.0174533. So this is the conversion factor. So you go to your calculator. So 53.13 multiplied with 0.0174533. What is that? To that you multiply 12. What do you get? You get a value of 11.12. Say 128 units. So L is equal to 11 point. I'm taking it to after decimal 3 places, 11.128 units. So this is the arc length. So what we have done today is class. We have learned quite a bit with regard to ensuring that the sides form the right triangle, and then we have utilized the length of the arc formula, and after that we have learned how to convert it if it is given in degrees to radian measure, and then get this arc length for this question. So this is a lovely question. You can practice it and we can move on to the next question.